Well, let's continue. We were talking about how does your computer run in program, and we talk about what CPU, what's its components. Now, suppose we have two processor from different manufacturer. One from Intel, one from Apple Silicon, one from Intel, one from AMD. Okay, uh, but these two processors share the same ISA. What was ISA? ISA was the instruction. Let me show. ISA was the instruction set architecture. Okay, so we have two different processors from two different manufacturers, but they share the same ISA. And what was this ISA? The instruction set. Okay. My question is that will they behave exactly the same? What's your answer? I have two different processors with the same ISA. Will they behave exactly the same? Yes and no. Yes, because they can run the same program, okay, and they will produce the same output. And no, because they have different speed, and they have different implementation and that ISA instructions. Okay, let me explain it a little better. If two CPUs both implement the same ISA, for example, one of the well-known of ISA was x80. Let's think both of them have the same ISA, x80. Both of them understand instructions such as addition, subtraction, move, comparison. Okay, both can run the same executable file, and the same operating system can be installed and can run on both of them. It's important. But why? It's because the contract between the software and hardware is the ISA, and because both of them have the same ISA, they can understand the same things. As long as the processor supports the ISA, the program can run. But why I tell you no, and because of the speed and how the instructions are executed, it's because the ISA just define what instruction exists, but it does not define how these instructions are implemented inside the CPU. The implementation is more important than the existence of instruction. This brings us to the concept of microarchitecture. You can consider that I have a processor Intel Core i9 as this picture, AMD Ryzen. Both use the x86-64 ISA. So if you run .exe file, both of them can process that and can execute that. However, one of them may execute the program faster. One of them may consume less power. One may have large cache, one may have a deeper pipeline, and something like this. You can think it about like that. Both of us, me and you, we can speak in English, and a native English can also speak English, but one of us may speak faster, one may have different accent, One may have better memory, and she or he can remind the word better than me. Okay, even so, both can understand the same sentences, but their speed is different, their knowledge is different. Okay, it's a good example of the different performance of processor with the same ISA.